Welcome to this deep dive, all about artificial intelligence.
Ooh, fun.
Yeah, when you requested this, I was really excited because AI is one of those things that's both totally sci-fi and already a part of our lives.
It really is weaving its way into everything we do.
It is. And to kick things off, we're diving into Chapter 1 of AI, A Modern Approach.
Yeah.
A textbook that's basically like the Bible for future AI experts.
It's considered one of the foundational texts.
Yeah, think of it as like a backstage pass to how the brainy folks are thinking about this whole AI thing.
It's a fantastic foundation for understanding this complex field, for sure.
Okay, so let's get down to basics.
What?
What exactly is artificial intelligence? It feels like everyone's just throwing that term around these days.
You're right. It's become a bit of a buzzword.
Yeah.
What's interesting is that there isn't one universally agreed upon definition. The book points out that AI is kind of like this big tent with different researchers approaching it from different angles.
So it's less about robots taking over the world and more about different ways of thinking about intelligence.
Yeah. Exactly. The textbook actually lays out 4 main approaches to AI.
Okay.
One is what they call acting humanly.
Okay.
Think of that sci-fi movie we talked about, where the robot tricks everyone into thinking it's human.
Oh, I love that movie.
That's the kind of thing this approach is getting at.
The robot was so convincing. Is that where the Turing test comes in?
Yes. The Turing test basically says that if a machine can fool a human into thinking it's intelligent, then for all intents and purposes, it is intelligent. But to pass that test, the machine would need a whole bunch of skills.
Yeah.
Things like being able to use language reason, learn, and even perceive the world like we do.
It makes you realize how much we take for granted with our own intelligence, all those things we do without even thinking.
Absolutely. And that leads us to another approach,
Okay.
which is all about thinking humanly.
Okay.
This one is about trying to understand how the human mind actually works. It's like those scientists who are trying to map out the brain.
So less about building a machine that acts human and more about figuring out the recipe for intelligence itself.
Precisely. But it's incredibly complex.
Yeah.
It's like trying to figure out how a super intricate clock works just by looking at the hands move.
Right. Then there's the approach that the Greeks would love. Thinking rationally,
Right.
which is all about using logic to figure things out.
You got it.
Yeah.
It's like that classic example they use in the book, all men are mortal.
Okay.
Socrates is a man,
Yeah.
therefore Socrates is mortal.
Makes sense.
It seems simple. But the challenge with this approach is that the real world is messy.
Yeah.
It doesn't always follow neat, logical rules.
It makes sense. Life throws curveballs. Logic can't always predict.
Right.
Which takes us to the fourth approach.
Yes.
Acting rationally. Is this the one that's all the rage in AI these days?
It's definitely the dominant approach. Right now, it's all about designing systems that can achieve their goals in the most efficient way possible, even if it doesn't look exactly like how humans think self-driving cars.
Right.
Or those robots that can sort packages in a warehouse.
So it's less about mimicking human thinking and more about creating systems that can get things done in the real world.
Exactly.
Yeah.
But this is where things get tricky.
Okay.
The book brings up this idea called the value alignment problem.
Ooh, that sounds philosophical. Tell me more.
Well, imagine programming a self-driving car.
Okay.
Your goal is to get the passenger to their destination as quickly as possible.
Right.
But what if that means the car starts breaking traffic laws?
Oh, no.
Or putting other people at risk?
Yikes. I see your point.
Yeah.
It's not enough to just make a machine that's smart. We also have to make sure it's smart in a way that aligns with our values.
That's the challenge, and it gets to the heart of why AI ethics is such a hot topic these days.
Yeah, it's like we're giving these machines so much power, we better make sure they're using it for good.
Right.
So we've talked about these different approaches to defining AI, but where did it all begin? Take us back to the early days of AI research.
Okay, buckle up. We're going on a quick time travel adventure through AI history.
Let's go.
The story begins way back in the mid-20th century,
Okay.
between 1943 and 1956, with this burst of optimism and groundbreaking ideas.
So what were some of the key milestones during those early years? I'm picturing scientists in lab coats hunched over giant computers excited about the possibilities.
You're not far off.
Huh.
This was the era of early neural networks,
Okay.
where researchers were trying to mimic the structure of the human brain with computers.
Oh, wow.
And there was this program called the logic theorist that was actually able to prove mathematical theorems.
A computer proving math theorems. That's mind-blowing.
It was a huge deal at the time.
Wow.
And of course, we can't forget the famous Dartmouth workshop in 1956,
Okay.
where a bunch of brilliant minds got together and officially coined the term artificial intelligence.
Okay.
That moment is considered the birth of AI as a field.
Wow, so the field is still relatively young considering how much it's already impacting our lives. So much has happened in just a few decades. It really makes you wonder what the next few decades will bring.
It does. Now, after that initial burst of excitement, things got even more interesting.
Oh,
From 1952 to 1969, AI research was fueled by this incredible enthusiasm, and expectations were sky high.
wow.
Researchers were developing programs like the General Problem Solver that seemed to promise human-level intelligence just around the corner.
That sounds almost too good to be true. Were they able to achieve that level of intelligence?
Well, as you might have guessed, things weren't quite that simple.
What happened?
From 1966 to 1973,
Okay.
researchers started to bump up against the limitations of these early AI systems.
Okay.
It turned out that scaling them up to handle the complexities of the real world was a lot harder than they initially thought.
So what did they do? Did they give up on AI altogether?
Not at all. Instead of trying to create these all-powerful general-purpose AI systems, they decided to focus on building more specialized systems that could excel in specific domains. This led to the rise of what we call expert systems from 1969 to 1986.
So they were basically saying, okay, maybe we can't create a machine that can do everything a human can do.
Right.
But maybe we can create a machine that can do one thing really well.
Exactly. And they had some pretty impressive successes.
Like what?
One example is Dendril, a program that could analyze chemical compounds.
Wow.
Which was a huge breakthrough for chemists.
That's cool.
And then there was MYCIN,
Okay.
this program that could diagnose bacterial infections almost like a digital doctor.
These expert systems sound pretty amazing, but if they were so successful, why didn't they become more widespread? What happened to them?
They definitely had their limitations. One of the big challenges was that they relied heavily on human experts to program in all the knowledge they needed to function.
Oh, so they had to have all that information beforehand.
And their scope was pretty narrow. They could do one thing really well, but they weren't very adaptable.
So they were kind of like those one-trick ponies. Amazing at their one trick, but not so great at anything else.
That's a good analogy.
What happened next? Did researchers find a way to overcome these limitations?
They did. The mid-1980s brought about a fascinating resurgence. Neural networks were back in the spotlight.
So they went back to their roots, but with a fresh perspective and new tools.
Exactly. And a pivotal development during this time was the backpropagation algorithm.
Okay, so backpropagation, I have to admit, that sounds a little intimidating.
Yeah?
Can you break it down for me? What is it and why was it so important?
Imagine you're teaching a dog a new trick.
Okay.
You give the dog a command, and if they do it right, you reward them.
Right.
If they do it wrong, you correct them.
Yeah.
Backpropagation is kind of like that. But for neural networks, it helps the network learn by adjusting its connections based on the errors it makes.
So it's basically a way of teaching these neural networks to learn from their mistakes and get better over time.
Exactly. And this breakthrough really paved the way for a lot of the advancements we're seeing in AI today, but the story doesn't end there.
Okay.
From 1987 onwards, AI took another interesting turn towards probabilistic reasoning and machine learning.
Ooh, those sound even more complex.
They are fascinating, though.
What were those all about?
Oh, up until this point, a lot of AI systems were based on this idea, pure logic. If this, then that. But the real world isn't always so black and white, is it?
Definitely not. There's a lot of gray area in life.
Right.
So probabilistic reasoning is about acknowledging that uncertainty.
Exactly. It's about dealing with probabilities and making decisions based on the likelihood of certain events happening, even if we don't have complete information, kind of like how we make decisions in our own lives, weighing different options and possibilities.
And what about machine learning? How did that fit into the picture?
Machine learning is all about teaching computers to learn from data without being explicitly programmed for every single scenario. It's like giving a computer a ton of examples and letting it figure out the patterns on its own.
So instead of giving the computer step-by-step instructions, we're giving it data and letting it figure out its own algorithms.
You got it. And this shift towards probabilistic reasoning and machine learning was fueled by another major development, the era of big data.
Big data, that's what everyone's talking about these days. I
Yeah.
can only imagine how much data we generate with all our gadgets and online activities.
It's mind-boggling.
Wow.
And this flood of data was like a gold mine for machine learning. It gave these algorithms a massive amount of information to learn from, leading to breakthroughs in areas like image recognition and natural language processing.
So it's like they finally had enough ingredients to cook up some really powerful AI.
Exactly. And this brings us to the current era, which is all about deep learning. This has been making waves since around 2011, and it builds on those earlier neural networks, but takes things to a whole new level.
Okay, I'm officially intrigued.
Good.
What's so special about deep learning?
Deep learning is all about training artificial neural networks with multiple layers, hence the deep part, on these massive data sets we were just talking about. And these deep neural networks can do some pretty amazing things.
Like what? Give me some examples.
Well, think about those facial recognition systems that unlock your phone or tag your friends in photos.
Oh, yeah.
Or those virtual assistants like Siri and Alexa that can understand your voice commands.
Right?
Those are all powered by deep learning algorithms.
Wow, so deep learning is already all around us.
It is.
I had no idea.
Even behind those programs that can beat world champion Go players and win on Jeopardy. It's a pretty big deal.
It sounds like deep learning is a game changer for AI.
It is.
So where do we go from here? What's the state of the art in AI today? What kind of things are researchers working on?
Well, there are a few key areas that are really pushing the boundaries.
Okay.
One is what they call artificial general intelligence, or AGI for short.
Okay, AGI, that sounds intense. Break it down for me. What is that exactly?
Imagine an AI system that doesn't just excel at one specific task, but can learn and perform any intellectual task that a human being can. That's the ultimate goal of AGI.
So basically creating a machine that's as smart as a human, if not smarter.
Exactly.
It's like something out of a science fiction movie.
It is.
Yeah.
But that's where a lot of the research is focused right now.
Okay.
And there's also a ton of work being done on things like natural language processing, computer vision, and robotics.
So machines that can understand and use language like we do,
Right.
see and interpret the world around them, and even move and interact with objects.
Exactly.
It sounds like the future is getting closer every day.
It really does feel that way. But with all these incredible advancements, there are also some important questions we need to consider,
Right.
especially when it comes to the ethical implications of AI.
That's a perfect segue to our next chapter.
Okay.
We've covered so much ground already, from defining AI to exploring its fascinating history.
We have.
Now it's time to tackle the big questions.
Okay.
The ethical dilemmas and the potential impact of AI on our future.
I'm ready when you are. This is where things get really thought-provoking.
All right, let's dive into those ethical waters. I have to admit, this is the part that both fascinates and kind of freaks me out.
I get it. AI ethics is one of the most important and debated topics in the field right now. It's not just about making cool technology. It's about making sure that technology is used responsibly.
Exactly. And we've already touched on some of those concerns with the self-driving car example and the whole value alignment problem.
Right.
But let's go even deeper. What are some of the other big ethical challenges we need to consider?
Well, one that keeps coming up is the issue of bias.
Ooh, that's a tricky one. How does bias play into AI?
It's kind of like this AI systems learn from the data we feed them.
Right.
And if that data reflects existing biases in our society, like gender or racial biases, the AI system might end up perpetuating those biases, even if we don't intend for it to.
So it's like the saying, garbage in, garbage out. If we train AI on biased data, we're going to get biased results.
That's the danger, and the book gives some really eye-opening examples of how this can play out in real-world scenarios. Like, imagine an AI system used to help judges make sentencing decisions.
Okay.
If the data it's trained on shows that people from certain backgrounds are historically given harsher sentences, the AI might recommend those same biased sentences, even if it's not fair.
That's a scary thought. It's a baked-in discrimination.
It is a concern.
So what can we do about it? How do we make sure these AI systems are fair and unbiased?
It's a multifaceted challenge. One important step is being really careful about the data we use to train these systems.
Okay.
We need to make sure it's representative and diverse, and that we're actively working to identify and mitigate any existing biases.
So it's not just about the algorithms themselves, it's also about the human choices we make when designing and training those algorithms. We have to be aware of our own biases and make sure they're not creeping into these systems.
Absolutely, and it's not a one-time fix.
Right.
We need to constantly monitor these systems, test them, and refine them to make sure they're not perpetuating harmful biases.
It's like ongoing maintenance for ethical AI. It can't be a set it and forget it kind of thing.
Exactly. Another big ethical concern is the impact of AI on jobs.
Yeah, that's the one I hear people talking about all the time. Robots are going to take our jobs.
It's a valid concern. And the book doesn't shy away from this issue.
Okay.
It talks about how AI has the potential to disrupt entire industries, leading to job displacement on a large scale.
So what can we do about it? It's not like we can just stop AI progress. It feels like it's moving too fast to stop now.
Right. And I don't think anyone is advocating for stopping progress. But what we can do is start thinking about how to adapt to these changes.
Okay.
This might involve investing in education and training programs to help people develop new skills that are in demand in the AI-powered economy.
So it's about preparing for the future and making sure people have the tools they need to thrive in a world where AI is playing a bigger and bigger role.
Exactly. It's about creating a future where AI benefits everyone, not just a select few. And this brings us to another crucial aspect of AI ethics, which is transparency.
Transparency. I've heard that word thrown around a lot in discussions about AI. What does it actually mean in this context?
It's about making sure we understand how these AI systems work, how they make decisions, and what data they're using. It's about being able to look into the hood, so to speak.
So we need to be able to see how the sausage is made. Otherwise, it's just a black box making decisions that affect our lives, and we have no idea why.
That's the danger, and that's why transparency is so crucial. If we're going to trust these systems, we need to be able to understand them. And this is especially important in areas like healthcare or criminal justice, where these decisions can have a huge impact on people's lives.
You're right. Blind trust in a system we don't understand is never a good idea.
Right.
So how do we ensure this transparency? Is it a technological challenge, or is it more about policies and regulations?
It's a bit of both. On the technical side, researchers are working on developing tools and techniques that make AI systems more explainable.
Okay.
And on the policy side, there are growing calls for regulations that require companies to be more transparent about how they're using AI.
So it's a combination of making the technology itself more understandable and putting rules in place to ensure accountability.
Exactly. It's about creating a culture of responsible AI development. And speaking of responsibility, there's one more ethical challenge I want to touch on.
Okay.
And that's the potential for misuse of AI.
Oh, that sounds ominous.
Yeah.
What kind of misuse are we talking about?
Well, imagine AI being used to create deepfakes that spread misinformation or propaganda.
Oh, wow.
Or AI-powered surveillance systems that erode privacy and civil liberties. Or even autonomous weapon systems that can make life or death decisions without human intervention.
Those are some pretty dark scenarios, it sounds like. We need to be thinking not just about the intended uses of AI, but also about the potential for it to be used for harmful purposes.
Exactly.
Yeah.
And that's why it's so important to have these ethical discussions now. While the field is still relatively young, we need to be proactive about addressing these challenges, not reactive.
It's like we're at a crossroads with AI. We have this incredible technology with the potential to do so much good, but we also have to be aware of the potential for harm.
You put it perfectly, and that brings us back to the book's point about the control problem. How do we ensure that AI remains under human control and that it's used to benefit humanity, not harm it?
That's the million-dollar question, isn't it? So we've talked a lot about the ethical considerations.
We have.
But I'm curious to explore another aspect of AI that you mentioned earlier, its philosophical roots. It feels like AI brings up some pretty deep questions about the nature of intelligence, consciousness, and what it means to be human.
You're absolutely right. AI is deeply intertwined with philosophy.
Yeah.
In fact, you could argue that many of the questions we're grappling with today about AI have been pondered by philosophers for centuries.
So it's not just about the technology itself, it's about what that technology tells us about ourselves.
Exactly. And the book does a great job of tracing some of those philosophical connections.
You're right.
Remember how we talked about that idea of the Turing test? Yeah. Can a machine fool a human into thinking it's intelligent? Well, that question gets at the heart of a long-standing philosophical debate about the nature of the mind and consciousness.
So are you saying that the ancient Greeks were already thinking about AI even though they didn't have computers?
In a way, yes. They were asking those fundamental questions about what it means to think, to reason, to be conscious.
Mm-hmm.
And those questions are still relevant today, even more so with the rise of AI.
Wow. It's mind-blowing to think that we're still grappling with those same questions that philosophers have been debating for millennia.
And it is.
So what are some of the key philosophical ideas that have influenced AI? Where should we even begin to unpack this?
Well, one interesting place to start is with the concept of dualism.
Okay.
This is the idea that the mind and the body are separate entities. The mind is non-physical while the body is physical.
So like a soul or a spirit that exists independently of the physical brain.
Exactly. And this idea has been around for centuries, with philosophers like René Descartes being big proponents of it. But if dualism is true, then it raises some tricky questions for AI.
Like, can a machine that's made of physical components ever truly have a mind or a soul?
Right, because if the mind is non-physical, then it's something that can't be created or replicated by physical means.
So dualism kind of throws a wrench into the whole idea of creating truly intelligent machines.
It certainly complicates things. On the other hand, there's an idea called materialism,
Okay.
which says that the mind is a product of the physical brain. Basically, everything that makes your thoughts, feelings, memories are all the result of physical processes happening in your brain.
So no mysterious soul floating around, it's all just neurons firing.
That's the basic idea. And if materialism is true, then it opens up the possibility that we could, in theory, create artificial minds by replicating those physical processes.
It makes you wonder if cracking the code of consciousness is just a matter of understanding the brain well enough to replicate it.
That's the big question, isn't it? And there are all sorts of other fascinating philosophical ideas that have influenced AI.
Okay.
Like there's functionalism,
Yeah, okay.
which says that the mind is defined by what it does, what it's made of. So according to functionalism, it wouldn't necessarily matter if a mind was made of biological neurons or silicon chips, as long as it performed the same functions.
So it's like judging a book by its cover versus judging it by its content. A mind could come in different packages, but still be a mind if it functions in the same way.
Exactly. And then there are all sorts of ethical theories that play into how we think about AI,
Okay.
like utilitarianism,
Okay.
which says we should aim to create AI that maximizes happiness and well-being for the greatest number of people.
So building AI that's not just smart, but also morally good?
That's the idea.
Yeah.
But of course, there's always the question of whose happiness we're prioritizing and how we measure well-being.
Right.
It's not always a straightforward calculation.
Yeah. Ethics are rarely black and white, and I imagine things get even more complicated when we're talking about AI, which is constantly evolving and pushing the boundaries of what we thought was possible.
You're telling me, and that's why it's so important to keep these philosophical conversations going as AI continues to advance. We're going to need to keep asking those deep questions about what it means to be human, what it means to be intelligent, and what kind of future we want to create with this powerful technology.
It's like AI is forcing us to confront these fundamental questions about ourselves, our place in the universe, and the very nature of existence. And speaking of confronting big questions, we've talked about the philosophical side of AI and the ethical challenges.
Right.
But there's one more piece of this puzzle I want to explore. The nuts and bolts of how AI actually works.
You mean the technical side, the algorithms, the data, the hardware?
Exactly. I think it's easy to get caught up in all the philosophical and ethical debates, which are super important, but I'm also curious about the actual mechanics of AI. How do these systems learn? How do they make decisions? And what are the limitations of current AI?
Okay, let's get into the nitty-gritty of it. Remember we talked about those 4 main approaches to AI?
Right.
Well, each of those approaches has its own set of technical tools and techniques.
So let's go back to those 4 approaches we've got: acting humanly,
Okay.
thinking humanly, thinking rationally, and acting rationally. Where do we even begin?
Let's start with acting humanly, since that's the one that captures the imagination the most.
Okay.
This approach is all about creating AI systems that can perform tasks in a way that is indistinguishable from a human being.
So like those chatbots that you can talk to online and you almost forget you're not talking to a real person.
Exactly. And for an AI system to pass the Turing test and truly convince us it's human, it needs a whole bunch of sophisticated tools.
Like what? Give me a glimpse behind the curtain. What are some of the technical wizardry behind these systems?
Well, one key area is natural language processing, or NLP for short.
Oh.
This is all about teaching computers to understand and use human language.
Right.
And it's more complex than it sounds. Human language is full of nuances, ambiguities, and cultural context.
So it's not just about teaching a computer a bunch of words.
Right.
It's about teaching it to understand the meaning behind those words and how we use language to communicate.
Right. And NLP involves all sorts of techniques like breaking down sentences into their grammatical components, analyzing the relationships between words, and even trying to infer the intent behind what someone is saying.
It's like teaching a computer to read between the lines. No wonder it's such a challenging area.
It is. And then there's computer vision, which is all about teaching computers to see and interpret images and videos.
Yeah.
Think about self-driving cars that need to be able to recognize pedestrians traffic lights and other vehicles.
Or those facial recognition systems we talked about earlier that can identify people in photos.
Exactly. And computer vision involves things like detecting edges and shapes and images, recognizing objects, and even understanding the scene as a whole.
It's amazing how much we take our own visual system for granted. We just look at something and instantly know what it is.
All right.
But for a computer, it's a whole computational challenge.
It is, and these are just a couple of the tools used in the acting humanly approach.
Yeah.
But let's move on to thinking humanly,
Okay.
which is a bit more about reverse engineering the human mind.
Okay, so less about mimicking human behavior and more about figuring out how human intelligence actually works. It's like those scientists are trying to map out the brain and figure out what makes us tick.
That's a great way to put it. And this approach draws on insights from cognitive science, psychology, and neuroscience. It's about trying to understand how humans learn, reason, solve problems, and make decisions.
So are they trying to build AI systems that actually think like humans?
Yeah.
Or is it more about using those insights to inform how they design AI systems?
It's a bit of both. Some researchers are trying to create AI systems that model human cognitive processes as closely as possible.
Okay.
They might use things like artificial neural networks, which are inspired by the structure of the human brain, to try to replicate how humans learn and process information.
So those neural networks we talked about earlier are kind of like a digital version of the human brain.
In a simplified way,
Yeah.
yes, they consist of these interconnected nodes that process and transmit information, kind of like neurons in the brain.
Right.
And these networks can be trained on data to learn and improve their performance over time, much like how humans learn through experience.
It's crazy to think that we can simulate the workings of the brain, even in a simplified way, using computers. It makes you wonder what the limits of computation are.
It does, and that's one of the big questions researchers are grappling with. How far can we push these computational models of the brain? Can we eventually create artificial systems that are as complex and adaptable as the human brain?
Those are some big questions.
They are.
But for now, let's move on to our next approach. Thinking rationally. This is the one that's all about logic and reasoning, right? Like Spock from Star Trek.
It's exactly. This approach focuses on using formal logic and mathematical rules to create AI systems that can reason and make decisions in a way that is demonstrably correct. It's all about following the rules of logic to arrive at sound conclusions.
So if A equals B and B equals C, then A must equal C, that kind of thing.
You got it. And this approach has been very successful in areas like theorem proving and expert systems where the rules are well defined and the problem space is relatively constrained.
So it's great for situations where there's a clear right and wrong answer, but maybe not so great for dealing with the messiness of the real world, where things are often more ambiguous.
That's one of the limitations of this approach.
Okay.
Pure logic can struggle to handle uncertainty,
Right.
incomplete information, and the kind of subjective judgments that humans make all the time.
Right. Life is rarely as neat and tidy as a mathematical equation, which brings us to our final approach. Acting rationally. This is the one that's all the rage these days, right? The one that's behind all those cool AI applications we see in the news.
It is, and it's all about designing AI systems that can achieve their goals in the most effective way possible, even if it doesn't look exactly like how humans think.
So it's less about mimicking human intelligence and more about creating systems that are intelligent in their own right.
Exactly. And this approach relies heavily on techniques like machine learning search algorithms and decision theory.
Can you break those down for me? I'm picturing a robot trying to navigate a maze, testing different paths until it finds the exit.
That's a great analogy for search algorithms.
Okay.
They're all about exploring different possibilities and finding the best solution to a problem. And machine learning, as we talked about earlier, is all about training algorithms on data so they can learn and improve their performance over time.
Just like giving a computer a ton of practice problems and letting it figure out the best way to solve them.
Exactly. And decision theory comes in when we're talking about AI systems that need to make choices in uncertain situations. It's about weighing different options, assessing the risks and rewards, and making the decision that's most likely to lead to a desired outcome.
It's like AI is playing a game of strategic chess, trying to figure out the best move to make to win.
That's a great way to think about it. And these techniques are being used in all sorts of amazing AI applications, from self-driving cars and personalized medicine to financial trading and fraud detection.
It's mind-blowing how far AI has come, and it seems like things are just getting more and more sophisticated. But with all these advancements, it also feels like there's some limitations to current AI. What are some of the things that AI still struggles with?
One of the big ones is common sense reasoning. Those things that seem obvious to humans but are surprisingly difficult for AI systems to grasp.
Like what? Give me an example.
Well, imagine you tell an AI system, I dropped the vase and it broke.
Okay.
A human would instantly understand that the vase breaking was a consequence of it being dropped. But for an AI system, that might not be so obvious, might not understand the causal relationship between those two events.
So even though AI systems can process information at lightning speed and do complex calculations, they can still trip up on things that seem like basic common sense to us.
Exactly. And another challenge is what they call generalization.
Okay.
It's the ability to apply what you've learned in one situation to a new, slightly different situation.
So being able to adapt and improvise, not just following a rigid set of rules.
Exactly. And that's something humans are really good at.
Right.
We can take what we've learned in one context and apply it to a new context without having to start from scratch. But AI systems often struggle with this. They might excel at a specific task, but if you change the parameters even slightly, they might not be able to adapt.
So they're kind of like those specialized experts we talked about earlier, great at their one thing, but not so good at thinking outside the box.
That's a good way to put it, and that's one of the reasons why people are still skeptical about the idea of truly general artificial intelligence.
Yeah.
Can we ever create an AI system that's as adaptable, flexible, and creative as a human being?
That's the big question, isn't it? And it's a question that's been fueling a lot of debate and speculation about the future of AI.
It has, and that's a perfect segue into our next chapter. We've covered the philosophical foundations of AI, the ethical challenges, and the technical nuts and bolts. Now it's time to look ahead and ask ourselves, what's next for AI? What are the potential implications of this rapidly evolving technology?
I'm ready to step into the future. Let's explore what this brave new world of AI might look like. Okay, so we've talked about where AI has been and where it is now, but where is it going? What does the future hold for artificial intelligence?
That's the million-dollar question, isn't it? The book doesn't offer any easy answers,
Right.
but it does give us some thought-provoking frameworks for thinking about the potential trajectories of AI.
So no crystal ball, but some helpful guideposts for navigating this uncharted territory.
Exactly. One way to think about the future of AI is to consider different levels of intelligence.
Okay.
We've already talked about artificial narrow intelligence, or ANI, which is
Yeah.
what we have today.
Right.
AI systems that are good at specific tasks, but lack general intelligence.
Right, those specialized experts, like the ones that can beat chess grandmasters or diagnose diseases,
Exactly.
but they're still limited in their scope.
Exactly. Then there's artificial general intelligence, or AGI,
Okay.
which is that holy grail of AI research.
Yeah.
Creating AI systems that have human-level intelligence or even surpass human intelligence.
So AGI is the one that gets all the hype, the one that sparks all those science fiction fantasies and fears.
It is, and there's a lot of debate about whether AGI is even possible, and if so, when we might achieve it. Some experts think it's just a matter of time, while others are more skeptical.
It's like those predictions about flying cars.
Right.
We've been waiting for them forever, but they still haven't quite arrived. But let's say hypothetically that we do achieve AGI.
Okay.
What then? What happens when we have machines that are as smart as us, or even smarter?
That's where things get really interesting and potentially a bit unsettling. The book talks about the possibility of artificial superintelligence, or ASI,
Okay.
which is AI that surpasses human intelligence in every way imaginable.
ASI, now that sounds like something straight out of a science fiction movie, the kind where the machines take over.
It does, and it's a possibility that we need to take seriously, even if it seems far-fetched right now. If we create machines that are smarter than us, how do we ensure they remain aligned with our values? How do we maintain control? These are the questions that keep AI ethicists up at night.
It's like that saying, be careful what you wish for, you might just get it.
Right.
We might achieve this incredible breakthrough in AI only to find that it comes with consequences we didn't anticipate.
That's the danger, and that's why it's so crucial to have these conversations now before it's too late. We need to be thinking about the potential impacts of AGI and ASI, and we need to be developing safeguards to ensure that these technologies are used for good, not for harm.
It's like we're building this incredibly powerful engine, but we haven't quite figured out how to steer it yet.
That's a great analogy, and that's why AI governance is becoming such an important topic. It's about creating frameworks, policies, and regulations to guide the development and deployment of AI in a way that is safe, ethical, and beneficial to humanity.
So it's not just about the technologists and researchers, it's also about policymakers, ethicists, and society as a whole coming together to figure out how to navigate this new landscape.
Exactly. We need a multidisciplinary approach to ensure that AI is used responsibly and for the benefit of everyone.
It's almost like we're writing a new social contract for the age of AI. We have to redefine our relationship with technology and with each other in a world where machines are becoming increasingly intelligent.
You put it beautifully, and that's why it's so important for everyone to be informed about AI, to engage in these conversations, and to demand that these technologies are developed and used in a way that aligns with our values.
So it's not just about the scientists and engineers, it's about all of us playing a role in shaping the future of AI.
Absolutely. The future of AI is not predetermined. It's being shaped right now by the choices we make, the conversations we have, and the actions we take.
This deep dive has been quite a journey. From defining artificial intelligence and understanding its different approaches, we've navigated through its history, explored the ethical dilemmas, and even peered into the future.
We've covered a lot of ground, and you've asked some really insightful questions.
Well, you've given me a lot to think about. I'm walking away with a newfound appreciation for the complexities of AI and a sense of both excitement and caution about what the future holds.
That's a healthy perspective. To have AI has the potential to revolutionize so many aspects of our lives, but it's important to approach it with both enthusiasm and a critical eye.
So as we wrap up, what's the one key takeaway you want to leave our listener with?
The future of AI is not something that's happening to us. It's something we are actively creating. We all have a role to play in shaping this technology and ensuring it is used to benefit humanity.
That's a powerful thought. The future of AI is in our hands. Thanks for taking us on this incredible deep dive.
It's been my pleasure.